Is it going? Yes. All right. This is for all the millions of Twitch fans. This is the practice. Good practice quiz. So the quiz is a decent number of questions. I think it's 19 questions.
Ew.
But a lot of
19. That's my favorite number. Sorry.
Okay,
So
left wing
loud.
destroyed. Okay, so the first one is just evaluating the integral. So that's pretty straightforward. I'm going to rewrite that as x to the -4th so I can integrate it more easily. So this would just be you add 1 to the exponent and divide by that new exponent. So it's going to be x to the -3 over -3. Everyone's okay with that, right? Cool beans?
Yep.
They're cool.
And then you plug, so then maybe rewrite that as -1 over 3x cubed. That's probably going to be easier to plug into. Plug in 2, you get -1 over, so 2 cubed is 8, right? 3 times 8 is 24. Minus, plug in the 1's a bit easier. Now, the hardest part, adding the two fractions together.
720.
Let's see how many, well, multiply this by 8 over 8. So really it's -1/24 plus 8/24, and you get the answer 7/24. We all feel okay about that? Are there any questions on any of those steppies?
I'm confused. Don't you do 1 minus 2? Like the integral of 1 minus integral evaluated at 2?
Well, no, you plugged it, what do you mean? You plugged the 2 in first, right?
Oh, I thought you plugged it at the bottom.
No. That one plugs in first.
Okay.
All right. Similar kind of question. You got 5 over root t. So I'm going to write that as 5 times t to the -1/2. The number going from 9 to 25. So what's the integral? Oh, sorry, dt. What's the integral of this?
It'd be 2/3.
1/2. 10.
Hold on. You got to
sorry.
add 1 to this would make this
1/2.
positive 1/2. And then divide by 1/2. What's that going to turn the 5 into?
10.
10. Everyone feel okay about this?
Yes.
Okay, now evaluate from 9 to 25. And that's just a square root, right? So you could rewrite it like this if you wanted. That makes you feel better. So you gotta plug in the 25 and then plug in the 9. So 50 minus 30
20.
is 20. All right. No issues there. Okay. For number 3, you got it's like a u cubed type deal. So you're gonna have to do a little bit of. Can you put that on the desk, please? All right. U cubed. So what do I need here? Need a 2 to be there. So that means I gotta put a 1/2 out here, because otherwise I've changed the size of the integral. That's not good, right? It's not okay. So now I've got u prime. So remember, u prime times u cubed is gonna turn into u to the 4th over 4. Everyone's comfortable with that idea? Yes? Okay. So this is going to be 1/2 times u to the 4th over 4, evaluated from -1 to 1. You feel comfortable with that? Yes? No? We're sure there's no questions?
Yes.
Okay. plug in the 1, you get 3 to the 4th. Let's see, 3 to the 4th is 3 times 3 times 3 times 3, so 9 times 9. 81. Okay, so 81 eighths minus, let's plug the negative 1 in. That gets you negative 1 to the 4th, which is 1/8.
Wasn't that nice?
So we get 80 eighths, which is 10. That's pretty neato.
That was a nice number.
Isn't that, yeah, it worked out pretty nicely, didn't it?
Mhm.
No questions, we're sure? We feel okay?
Yeah.
Jason, you're not gonna write any of this down, Dylan?
Well, I
in there.
learned if I write it down, I don't take the practice quiz at home.
Wait,
Yes.
if you plug in -1, wouldn't it be 2 times -1 plus 1, which is -1?
And then, so then you gotta raise it to the 4th power?
Oh, I did it.
Makes it 1?
backwards.
Positivo.
Okay.
Still feel okay? All right. The next one has an absolute value in it.
Ooh.
Do we have any sort of fancy techniques for
Okay.
Graphy. I don't know, graphing.
Yeah, you gotta graph this one. Excuse me. So this is a shifted down. Those are all 2s. Okay, so I go all the way to -6. 1, 2, 3, 4, 5, 6. What's the y value at -6 for this function? 4. So this little triangle here, let's think about this triangle. Is everyone okay with how this area represents from -6 to 2? Which is what the integral is asking.
Mm-hmm.
So how much positive area is this? 4 times 4, right? Which is 16 divided by 2, so this is 8. Positive 8 plus, this guy is 4 times 2 divided by 2, which is -4. So what's the answer? 4. Does that make? Yes.
What did you get for the area for the other?
This one was, so we went 4 base time, 1/2 base time side, so 4 times 2 divided by 2. So this guy was -4. This guy was positive 8. So if you add those up, you get 4. Does that make sense?
Mhm.
Yes? Okay. All right. This one, you got, the answer choices should give you a pretty good hint here. If this ends up being free response, though,
That's right, because we got on paper.
you'll have to be able to recognize. That's a famous form, right? What shape is that? Semicircle. Okay. Of what radius? Okay. So, oh, sorry, we're only going from -8 to 0. So really, it's just this piece. So what proportion of a circle is that? A quarter of a circle. So you'd go a quarter of pi r squared. Right? The whole circle has a radius of 8. So the entire circle would have a radius of 64 pi. And so we're just going to have an area of 16 pi. Still feel okay? No confusion? No?
I'm still on the last one. How'd you get 4? -4.
So this right here is a triangle, right?
Oh,
This
never
little
mind,
piece
I'm
here?
done. I'm sorry.
It's okay. Feel free to ask if you have any questions. I'm glad to attempt to answer them. I can only do my best.
Mhm.
I think the Mars donut tastes good. Well, Caleb, you would have known yesterday, but.
Yeah, I think it's lazy.
That was good.
It wasn't lazy, I forgot. After you talked about it all day. Yeah. Easy to do.
Do you know donuts actually help you build lots of muscle?
Oh, wait.
Yeah.
Actually.
Well,
Let's count.
I know every nutritionist would disagree, but my cousin told me that he ate a lot of donuts and got really, really shredded. So
It's the same one as the coronavirus wasn't real.
Before the game's
Yeah, it's the same one. It's the same one.
We get second, you're buying this whole Red Bull.
I saw a meme on Facebook that said eating 6 donuts a day will help you get absolutely shredded. You'll look
Oh
like
God, I
Brad
could
Pitt
never.
in Fight Club.
I think it's probably-
6 donuts a day, though.
Oh, I'd feel so sick.
Wash them down with whole milk.
I could barely do one donut.
Yeah, I mean, I could do 2 pretty easily, but
Okay.
Well, one donut a month is good.
but that's just a week. You know, like 2 days a week.
Oh my
I think
That'd be insane.
permanently.
How much days? That's good. It's the seed.
All right, so here's just a little strategy hint for you. The way I write these, the word problems typically have much easier expressions to integrate. Like you might have noticed, those first couple integrals were a little bit more on the challenging end, right? Like required, like getting a U prime factor. If it's a word problem, you can expect it's probably going to be most of the time a slightly easier integral. So like in this one, how do you get the displacement? If this is the velocity of a particle, how do you get the displacement between time 1 and time 3? There's a little bit of vocabulary in this one, guys. So you have to understand that displacement is not the same as position, right? Displacement would just be the integral of the velocity function between time 1 and time 3. Does that make sense? Okay. So, so the integral of this would be t cubed minus 2t squared. Everyone's fine with that, right? Then you evaluate from 1 to 3. Everyone's still fine with that? Okay, so now you plug in 3. So this is maybe a little tip that'll help you avoid mistakes. Just kind of draw out, right? I'm going to plug 3 in and get an expression here, and then plug in 1. So plugging in 3 gets me 27 minus 18. Plugging in 1 gets me 1 minus 2. Fine. So 9 minus negative 1 is 10.
A lot of 10s.
Feelies okay?
Yes.
Pretty straightforward.
All right. This is not easy material. I'm just trying to make sure there's no confusion. This stuff's pretty challenging. So, what? The answer was 10. All right. Find the area of the region bounded between these curves. Okay. We're going to actually go over, we're going to start covering some more complicated questions like this. But for now, if you actually draw this out, you'll realize that here's the 3 root x curve. Here's the x equals 4 curve. And here's the x equals 9 curve. And then, of course, y equals 0 is just this axis here. So do you see how this is really just asking you for the integral value? It's that makes sense? Really, this is just asking what's the integral of 3 root x from 4 to 9. No tangents. They do it to me.
You know they had to do it to you.
Why did they? Yeah, they had to do it to me.
They had to.
They had to do it to me.
Yeah,
They're just being awkward.
a week.
Oh my God. What'd you guys do? Tell on me.
Why would we tell
I would
nobody?
accept
That would be our comedy.
Say,
for the day.
a mysterious accident has befallen my monitor. I don't know what happened.
There's a fist.
There's just a big-
There's a student who's behind the monitor.
Somehow, the
All
computer went out the window.
Oh my God.
We're not really sure, but the computer.
I have a funny story about computers really quick.
He was.
Earlier this morning, Senora couldn't get, all of a sudden, all these ducks just kept popping up on her computer. And she was like, it's a virus! A virus! What is happening? And it was like, duck memes were coming. It was like, honk, and there were ducks like waddling across her computer. And it turned out that Brandon got in there and did that somehow. So she was like, I'm gonna have to throw this computer out. We're like, no, Senora, it's just
Did he say
Brandon.
it's just a prank, bro?
Really
Okay,
Yeah. She almost called the IT people though.
What's the new exponent? When you integrate this term, what's the new exponent? 3 halves. So you're gonna have x to the 3 halves. Okay. And then when you divide this by 3 halves, you get 2. Is everyone okay with that arithmetic?
Seems.
Okay. Again, you can double check your answer very easily, right? 3 halves times 2 gives me 3. You can just take the derivative to reverse it and check your work. Okay. So now we got to plug in 4. We got to plug in 9. Okay. So plugging in now, it's up to you how much you have to jot down to keep your thoughts straight. I mean, you might need to write out 2 times 9 to the 3 halves if that's what makes it work for you. But if you can do it mentally, that's great. What's 9 to the 3 halves power? 27 doubled is?
How do you get that?
54.
I get the 27.
Okay, so 9 to the 3 halves is the same as saying the square root of 9 cubed.
Oh.
So usually it makes the most sense to do the root first.
So the bottom number is always like, is always the root then?
Yeah. Generally, x to the a over b power is the bth root of x to the a power.
Okay, cool.
Right?
Ew.
Plug in the 4 in, square root it, 2, cube it, 8, double it, 16.
Oh, forgot the double.
Okay? Make sense?
Yes.
So what do you get there? 38?
Yes.
Which is a possibility.
Okay. Now, on number 8, hang on, maybe move this over a little bit. Gosh darn it. Golly jeepers. Gosh golly.
Thanks, Charlie.
Gosh golly. I think it's probably stable. What do you think? Whew, stable. All right.
I would be so motion sick watching that.
Just don't feel motion sick.
Don't.
Yeah, that's all I
You didn't take Dramamine before you watched the stream, bro? That's on you. That's your bad decisions.
True. That was a choice.
Yeah, that's
That
just
was a choice
you're
that
suffering
you
the consequences
didn't
of
make.
your bad decisions for not taking tons of Dramamine before you watch YouTube.
You go down.
You're the program.
That's why I'm just gonna put randomly just horrific, harsh noise in at like way above the max volume, and then say you should have been wearing earplugs. Sorry,
You gotta be prepared for emergency.
you gotta be prepared for emergency and Emergeville. Yeah, some pulse demon.
Those are the
Okay.
worst videos that start out with like such an over the top volume of an intro. And then the audio's like so quiet you can't really hear it.
I'm gonna start doing that. It starts off like, oh, I can't really hear it. I turn the volume way up, and then just that's what it'll do. Feel like you should have been prepared. You should have been ready for that. Okay. All right. Look at this. This says that this is the graph of f prime. So the big idea here is right, the integral of f prime between, what are the two x values that are relevant?
0.
7 and 0. So the integral of f prime from 0 to 7 dx is really just f of 7 minus f of 0. Does everyone feel comfortable with that fact right there?
Correct.
We sure there's no questions? Okay. This value can be got from the picture, right? It won't be, you know, a super complicated shape to figure out. So you just have to go, what's the area? Well, let's see. 3 times 3 divided by 2, right, is, 9/2 or 4.5. And then I've got 1, 2. So minus 2. And then there's one more little piece of nougat there. Just be careful, like it says 7, so are we actually counting 7? Right, that's actually 7. So 5 minus 2 is 3. Yes. Yes. So this area is 3, the integral is 3. Okay. F of 7, they told us, is 11. So what's f of 0? 8. Any questions on that? Or we feel good about
Why
that?
is it there? Isn't it two?
What?
Isn't there two?
That's the answer.
Did I mess up?
No.
It's, say you take 4.5
That's
plus
correct.
0.5, that's 5.
Oh, it's plus three.
Yeah, so this is positive area. Yeah.
You don't.
I don't know f of 0. That's the goal, is to find f of 0. But I was able to find the integral by calculating the area, right? So you get how I got the 3, right? And you get how I got the 11? 11 was given.
So 11 is the area of all the things combined.
No, 11 is the y value of f. Remember, this is the graph of f prime. So 11 is the value of f when x is 7. So what we're doing here is relating the integral of f prime to a difference of values of f. I'm not sure if this helps you understand it better, but if this was a velocity graph, then this would be telling you the position. That would be telling you the position was 11 at time 7. Okay, number 9. Same idea. Same question pretty much, okay? The integral from -1 to 7, because why did I pick those x values? Because those are the x values that we're kind of focused on here, -1 to 7. The integral of f prime would be f of 7 minus f of -1. So same idea as before. How much area can we get between -1 and, let's see, 3, 4, 5, 6, 7. So that is the full graph. Let's go piece by piece here. So like, for example, this block here, I'm sure as you guys have been doing these, there's a lot of ways you can kind of reason these out, but this is 5, right?
Yes.
So 5 plus this little triangle contributes 2, plus this circle is half of pi. And then we've got like, you see how those two just kind of cancel out? Positive half, negative half cancel out. And then you got an extra -1 here. Does that make sense?
Yes.
So this is going to be 7 minus 1, 6. 6 plus half a pi. 6 plus half a pi equals 10 minus stomach ache.
Yeah, half of a pie, that's a lot.
That's a
Plus 6?
Speaking from experience, no?
Oh, yeah. Pumpkin
So
pie, all the
what
way.
you're going to have is 4 minus half a pi. That makes sense? That last step? I can think of it as maybe adding this over and then subtracting these guys from the right-hand side.
Yeah.
You're going to end up with 4 minus half pi. Cool beans? Everyone's comfortable?
Yes.
Okay, I just now remembered that. That is, oh gosh.
Okay. There's a question like this. Another one with a graph. It says, given this graph of y equals f of x, what's the integral of x plus f of x between 2 and 5? So here's 2 and here's 5. So the process on a question like this is first to go, well, like, do we all get how I'm gonna split this up into integral of x plus the integral of f. So I'd have to know, well, what's the integral of f between 2 and 5?
Ooh, that was good.
Looks like it's 3 plus 3. So I know that the integral from 2 to 5 of f is just 6. Everyone okay with that?
Yes.
Well, what's the integral of x between 2 and 5? That one's a little bit, maybe a slight pain in the bottom. Because you got to do 1/2 x squared, right? Plug in 5, you get 12.5. Plug in 2, you get 2.
Yes.
So it's 10.5. Is this, we're still fine?
Uh-huh.
So let me write on the board a little bit. Anyone know what time our class is over today?
Oh, no.
Guys are sending us an email, I can't remember what it was.
Oh, wasn't it like 43 or something?
Yeah.
Let me check my Snapchat.
My lunch starts at 43.
Third period
Oh,
is at
this class
10:50.
and,
Then when the bell rings.
So everyone hopefully is comfortable with what we're doing here. What you're doing here is you're basically going, well, that integral is just the integral of x from 2 to 5 plus the integral of f of x from 2 to 5. This is something you can this is just on its own a calculus question, the answer to which is 10.5, right? And then this we got from the graph, which was 6, so the answer is 16.5. We feel okay about where the 6 came from? Was the area between 2 and 5. So this rectangle plus this triangle made 6. All right. This is more of a conceptual question. This is a graph of f of x. And then it says consider some area function. This is what we were talking about the other day. There's some area function, an accumulator function basically that where a of x is just the area under this f curve between 0 and your choice of x. Where would the area function have a local min? So there's different ways you can think about this one. One way to think about it is kind of like, well, every time f is negative, we're actually accumulating negative area, so the a function is decreasing. So if f changes from negative to positive, that means that the area function is changing from decreasing to increasing. Okay. So here at 1, we'd have a local min because it's changing from negative. And again, you can think of this in terms of the general. If f prime, right? If you're doing like an f prime to f, if f prime goes from negative to positive, then f is going from decreasing to increasing, which would be a local min. So the answer is 1, and where else? 4. No, 4 we're changing from positive to negative. That would actually be a local max. 6. So 1 and 6 is the answer. Yeah, be careful. 4, it would be a local. Everyone understand why 4 is a local max? Positive, negative. Yeah, because it's changing. Because look at this. Think of the a function: gaining area, gaining area, gaining area, gaining area, and now it's losing area. So that a function would be increasing and then start decreasing when you hit 4. Okay. There's a whole bunch of conceptual questions on here that should be really fast, like this one. If a particle has a velocity function v of t, what's the meaning of this? It's just a straight up integral of the function from 2 to 7. Does it tell you the distance?
No. Displacement.
This is the displacement. This tells you the particle's overall displacement from 2 to 7. If you were tempted to think about something like position, the position would have to be like, say, so the answer to, so if you wanted the particle's position at time 7, you would basically need v of 2, I'm sorry, my bad, x of 2, right? The starting position plus that displacement. That would be the position. at time 7. So without a starting position, that's just going to tell you the overall displacement. Albert is running back and forth along a one-dimensional track with his velocity given by the function v of t, and at time 1, his position is 23 meters. Which expression represents the distance between Bob's position at time 1 and his position at time 7? This one is Mr. Toadman. Say Mr. Toadman. Because I threw this word in here. But you're not actually being asked about distance, are you? You're being asked for the distance between his two positions. What is that actually called? That's called displacement. So be careful. Everyone okay with that? That's capital T. They try to pull the Mr. Toadman on you, right? So you can say displacement, or you can say the distance between your starting and ending point. Yeah? Okay. So the answer to this one is just A, the first one. That's the displacement. Are we okay with that?
Yeah, sure.
Okay. This would be just the distance he traveled. This would be his position at time 7. You okay with that? Distance traveled, integral of absolute value of velocity. Starting position plus displacement would be his position. The rest of them are kind of meaningless, more or less. All right. Gas flows in and out of a balloon at a rate given by a function r of t. And at time t, the tank contains 100 liters of gas. Which of these functions describes the volume of gas in the balloon as a function of time? So this is another one. You need start plus, let's call it displacement. You can have volumetric displacement. So like the starting amount plus the accumulation. So at time 3, he had 100 liters, right?
Yep.
So first, rule out the ones that don't involve the 100. Those can't be right. What's the problem with C?
Zero.
That pesky 0, that's wrong, right? Same thing here. E is also wrong. I don't want the absolute value of the rate function.
Oh.
I want this. Does that make sense? This is basically v of 3 plus the integral of the rate function between 3 and time t. Okay?
Mm-hmm.
Everyone's fine with that?
Mm-hmm.
All right. A particle is traveling along the x-axis and its velocity is given by the function v of t, and at time 3, the particle's position is 25. Which expression below gives the total distance traveled by the particle from 3 to 8? Who knows it? Not F.
C.
It's
C?
D.
D? Now that's thingies.
Distance traveled, right?
Another reason.
Distance is always positive, right, guys? Okay. Distance. By the way, this is a subject that there's not a ton in calculus that warrants like note card style studying, but this might be one. You need like 4 or 5 note cards because you talk about I got a rate function, let's say a velocity function, right? Which one is the distance? Distance is integral of the absolute value of the velocity. Displacement is just the integral of the velocity. How about position? Position would be the starting position plus the displacement, right? And then anything else would be fairly, like this is pretty much meaningless. Does that make sense why that's meaningless?
Yeah.
Like adding your starting position onto your distance traveled, that doesn't really tell you anything, right? Because like what if I just, a quick example, what if I started at position 25 and did this? Let's say I traveled, let's say my distance was 1,000 meters. Well, what's the meaning? And I ended up back where I started. What's the meaning of 25 plus 1,000? Doesn't really mean anything, right?
Yeah, yeah.
We're nodding.
I'm just trying to make sure, I'm trying my best to give you some good intuition on what these things mean, what they're saying.
Oh.
What? Okay, these are what we were looking at the other day. So you've got basically, the integral of f from 1 to 6 is -6. And you know the integral from 4 to 6 is 2. What's the integral of double the f function from 1 to 4? So I thought a lot of you guys are having some issues with these. Your issue most of the time was you were trying to do it all at once. So here's how you do this one. You go the integral from, would you all agree with this? I'm going to use really, this is really shorthand here, but I think it helps avoid some clutter. You all agree with that statement, hopefully. That should be pretty self-evident, okay? Now they told us this number, right? -6. They told us this number. Or no, sorry, we don't know this number. We know this number. We know from 4 to 6 it's 2. Right? So then how big is this number? -8. So what's the answer to the question?
-4?
-16.
Oh, that's right.
Oh, negative, yeah.
Because we now know that the integral of f from 1 to 4 is -8. So what happens if you double f? You double the integral, wouldn't you? Right? Because the integral of 2f is the same as 2 times the integral of f. So if we figure out that this is -8, then this has to be -16. You sure we feel okay about that? Okay, so 17, we're almost done. If the integral, now notice the bounds are the same on all of them, right? 0 to 2, 0 to 2, 0 to 2.
Okay.
So if the integral of f minus g, we know that the integral of f minus g is equal to the integral of f minus the integral of g, right? So if they tell us that this is 22, and they tell us that this is 6, then how big is the integral of g between 0 and 2? -16, right? Make sense? So the integral of g from 0 to 2 is -16. So what's going to be the integral of 4 times g over that same interval? -64. Yeah? Yes? So you agree with the first part, right?
Yeah.
And then do you agree that this was given?
Yeah.
And then this was given, right? So 6 minus what makes 22? You could call that like an x, basically. Call it question mark and solve for it. Does that answer your question?
Yeah.
All right. Last two. We know. So this one says, we know that the integral from 2 to 5 of f is 6. So the thing we're trying to evaluate is the integral from integral of 2f plus 1. So basically we have, here, you guys stop me if I confuse you here. Does that make sense? Yeah. So you split it up. So the integral of 2f plus 1 is the same as 2 times the integral of f plus the integral of 1, keeping all the same bounds. Oh, I'm done. Oh, did I Dramamine?
Do you do 2 times, like say f was 16, would you do, it's not, but if it's like, would you do 2 times 16 plus 1 or 16 plus 1 times 2?
More like the first one, but not quite, because what you're going to do, well, they give us 6, right? Let's just use the 6. So how big is this thing right here? 6. So 2 times 6. But wait a second, what's the integral of 1 from 2 to 5? It's going to be 3. Oh, you could integrate, yeah, x. So you could evaluate this like, oh, it's x evaluated from 2 to 5. 5 minus 2 is 3. long story short, you get that basically f contributes 6. So if you double 6, you get 12. And then that 1 is going to contribute 3 units of area to the overall integral, so you're going to have 15. Last one is just an old fancy schmancy of which of these has this property of, this is what we talked about, I think, at the end of class yesterday, right? Between negative a and a, for any choice of a, the integral will always be 0. That just means it's an odd function, so it's got to be 2 only. 2 is the only odd function on there. All right, have a nice weekend.
You too. See you in 2 weeks. And how do you want Jesse and I to take the quizzes? You could just email us the password.